So this is kind of cool. So yeah, I used to live in the Bay Area, and actually my first talk that I ever gave was at Piggy's, like 20 years ago. So yeah, so kudos to them for keeping it up. Okay. So let's talk a little bit about, I assume everyone here kind of knows about Pandas and what Pandas is, maybe. Who here uses Pandas? Okay, who uses it like at work in production? Okay, cool. Who here uses Polars? Who uses it at work in production? Okay. Cool. Awesome. So a little bit about me, just why I'm talking about this. So my first job out of school was doing natural language processing with Python. This was before a lot of today's tools existed. And then later on, I created this OLAP engine in Python, and then I heard about Pandas later on, and I started using it at work. And then at that point, I had started getting like the book writing itch, and so I wrote a book about Pandas. And then I started doing a bunch of training about Pandas and did like some Spark training as well. I did the second edition of the Pandas cookbook, and then after doing a bunch of training and consulting on Pandas, I got, and maybe I just graybeard or curmudgeon-y, I got a lot more opinions about like what code should look like and what it shouldn't look like. So I don't know if any of you like follow me on the internet or whatever, but you know, one of the ways to get a lot of attention on the internet is to post some code and say like, you consider this a best practice, and you'll get a bunch of hate mail and death threats. Okay, not death threats, but close. Basically, like I would never hire you, and you're like my worst nightmare sort of things. And then I did, you know, some more stuff with QDF and Modin, Polars. I wrote Effective Pandas 2, and then I wrote Effective Polars, and then a subsequent edition of that because Polars is moving so quickly. So, you know, the previous talk talked about like these large language models, and that's kind of the cool thing today, AI. And so why tabular, right? This is like boring stuff. And my operating theorem here, and the sample size 1, is that most people have their crown jewels sitting around in an Excel spreadsheet somewhere, and or a SQL database, right? And it's in tabular form. And I think a lot of people are either just ignoring that data, or people who are extracting value out of that data actually extract a lot of value out of that data, and they don't necessarily want to share it with the world because it's so valuable. So a lot of my work I spend most of my time doing corporate training these days, but a lot of my work is focused on tabular. You know, the Pandas, Polars, XGBoost, CatBoost type stuff, because my clients are finding that they're in this world where there's sitting on a bunch of tabular data and they want to extract value out of this. So, you know, like I said, I've been using Python for over 20 years, and the sad news is that Python is not a fast language. I hate to break that to you here. If you came here thinking that Python is fast, it is not fast. It's actually really slow. And so probably I would blame like the reason why I have a job today is probably based on NumPy. And so NumPy is, you know, most of you are using Pandas, and so I'm probably preaching to the choir, but NumPy gets around Python slowness by saying, okay, instead of treating everything as an object, we're going to abstract a Python interface for a bunch of numbers. And then we basically have the overhead of C, and if we stay inside this NumPy sandbox, we basically get the speed of C, but we're writing Python code, which is pretty nice. A lot of people like that. You know, some people don't like Python because white space scares them or something like that. But a lot of people are like, yeah, I'd prefer to write Python code rather than C or Fortran. And NumPy is not perfect either, and so Pandas 2 also has an optional backend called PyArrow, which kind of fixes some of the warts and issues of NumPy. Okay, Polars, it is a Python library, but it gets around Python slowness by having a backend written in Rust, and it implements this arrow standard. So the nice thing about a lot of these tabular data libraries going forward is they have some interoperability. So we can do a lot of operations, like if I'm using Pandas 2, I can do like 0 copies into things like DuckDB or into Polars, and it's just fast and kind of works, and we get around like the Python slowness. But again, one of the important things to be aware of is that we have to stay within this playground, right? There's this playground of NumPy where if you can go out of it, but when you go out of it, sort of all bets are off. You're sort of in slow land again. And Pandas has the same thing, and Polars to some extent does as well. So, why... I'm going to be talking about I'm just going to go through an example of data. Sorry, I'm going to try this. Can you hear me? Is it on? Okay, sorry. I feel like I do better when I'm moving around. So I'm going to move around a little bit. So I'm going to show an example of a data set that is kind of personal to me. So last week, so does anyone here ride bikes? Few people? Okay, so my kids are on the mountain biking team, and so we ride bikes multiple times a week. And last week, I was sweeping the team that I ride with, so that means I'm the last person. And I distinctly remember, one of the things I remember on this ride is, as I'm flying through the air, thinking, I hope the person in front of me hears me crash. So we were doing a trail, and I basically endoed, and that's one of the things I remember from that night. I remember a couple other things. So when I came to, I got to the person in front of me, and they're like, oh, I waited for you for a few minutes. I even called you on the phone. And I'm like, oh, okay. And they're like, you said you couldn't come to our ride on Thursday. And I'm like, I did? Oh, yeah, I did say that. But I couldn't remember why. She's like, why couldn't you come? And I'm like, I don't know why. And so then she's like, you better walk down the rest of the trail. And so we're walking down, and then like 5 minutes later, I'm like, oh, I remember why I can't come. It's my anniversary. She's like, well, you're not going to be making out on your anniversary. Turns out that I had basically landed on my face, and so my lower lip was basically separated from my jaw. I'm pretty good now, but last week I was pretty banged up. My jaw is still a little stiff. So the data set that I'm going to be looking at is my Strava from when I crashed. And I loaded it up because I was curious. She's like, I waited for a few minutes. I'm like, okay, I can't remember like blacking out. All I can remember is me crashing and then like thinking, I hope she hears me crash, like oof or something. And then the next thing I remember is like waking up and taking a selfie to see like how many teeth I was missing, sort of thing. So I'm going to look at that data set. It's anyone here messed with Strava data before? Okay. So my point in telling you that is that like the process that I'm going to be going through today is kind of generic. It's not like specific to any data set per se. And I've given talks similar to this where I look at different data sets. And so I'm just going to be walking through this data set, and my goal was to actually like find out like how long I was out for based on that. But because I was looking at it, I'm like, oh, I might as well like just speak on this at the conference today. So that's what we're going to do. We're going to load up this data set. I'm going to talk about my process for dealing with tabular data here. Okay, so polars, a little bit about polars. I mean, it sounds like most of you are familiar with pandas, and like 2 of you have used polars. So maybe I'm going to give you some reasons why you might want to and might not want to use polars. So again, polars basically says people want to use Python. Python's the most popular language for data science, but Python is slow, so we're going to get around that by writing it in a fast language. Polars also has the notion of, we've got 50, 60 years of database technology behind us for dealing with tabular data. Why don't we take that into account and build a query engine so that we can do things in an efficient manner? Pandas is really naive. Pandas just sort of does things, and it doesn't really take advantage of history that way. And so polars, has lazy evaluation as well, so it actually has a query engine. It can go back and look at what you're doing and plan and be smart about that. It can do query optimization. It can use multiple threads, and the API is different from Pandas. So a lot of people are like, well, I'll just use Pandas and then I'll just convert it to polars. No, you can't really do that. If you're using polars, the API is different. And so one of the things to be aware of with these APIs, at a high level, there's these things called contexts and expressions. Expressions you can think about, they select data, and then context is a way to describe an operation to your data. So if you stay within the sandbox of using these contexts and expressions, basically you can take advantage of the speed of polars. Okay, so again, you can just pip install polars. It works pretty well. I'm going to load my data. I'll just walk through this. Okay, so go back to this mic. Okay, so I'm loading this GPX library. That's a library for dealing with Strava exports. And then I'm loading NumPy and polars. Polars is commonly aliased as PL, just like Pandas is aliased as PD. I'm using polars, I'm using polars version 1.7. So that's another thing to realize is that polars is a library that moves pretty fast, which is kind of cool because the developers of polars are super responsive. But it's also, if you're kind of in we choose boring technology because boring technology just works, right? That might be problematic for you because polars are moving really fast. I mean, the changes aren't really super breaking, but it does release quite often. I mean, I think version 1 came out 3 months ago or something, and now it's at 1.7. So they are super responsive, though. Okay, so I've got some code here. This is just parsing code. It's parsing this GPX file. This isn't super interesting, so I'm going to kind of skip over this because let's just assume that you can load up your CSV file or read from a table. So here is what our data looks like. So this is a polars data frame, and you can see it shows the shape there at the start, and then it shows our columns there, and below the columns it has a type. So again, F64 is not a Python type. That's a 64-bit floating point number, right? And it's got this engine written in Rust that stores those and operates those in an efficient manner. And if you're used to Pandas, this looks pretty similar to a Pandas data frame. It's not showing you all the columns. It's got an ellipses there. It's not showing you all the rows. So pretty similar, except it has those types above that. We can ask what the size is of this. So this is not big data by any means, right? This is 1 meg of data from my crash. And another thing to realize here is that if you look at this, there is no index in polars. So a lot of people who are used to Pandas are used to using the index, and polars does not have an index, for better for worse. So I think the index makes some things easy, some things are weird, and some things it's why is that in the index? Shouldn't it be a column? Polars are just we don't believe in the index, so we're not going to have one. And we get around okay without that. If you want to stick in an index, you can do something like this and just add in a column that simulates an index there. Okay, so let's assume, a client gave me a CSV file or something, and who here deals with CSV files? Okay, almost everyone. Who here likes CSV files? Some people do. I mean, they do have some value, right? Like, almost everything can read them, and they're human readable to some extent. But that's about the extent of the value, right? They don't have type information in them. There wasn't really a standard for CSVs for many years, and then when the standard came out, it's like kind of too little too late. So, parsing CSVs is kind of a non-trivial thing if you want to parse like 99.9% of the world's CSVs. And you can look to like just the Pandas read CSV code for that. It has like 50 different parameters for parsing these CSVs. So not fun, but a lot of the world, like I said, a lot of the world's values is sitting around this tabular data, and it turns out CSVs is part of that. And so, I spend a lot of time cleaning up messy data in the spirit of Big Data Borat, who said something like 80% of data science is 80% clean data and 20% complain about clean data. That sounds about right to me. I spend a lot of time cleaning data, and Pandas and Polars, these tools make it relatively good to do that. So let's clean up this data a little bit. I can ask this for columns. A lot of this is similar to Pandas, but it's not exactly the same. So, I can ask, what are the columns here? Here are the columns. So I'm just going to make a little variable that has those columns in there, and then I'll index and pull off those columns there. And then we can ask it what the D types is. This is similar to Pandas as well. So you can see this first one is a null D type. For whatever reason, my Strava export didn't have a name on the course. So that's just empty. But you can see that it actually parsed the date for us, which, I didn't ask it to, but it did that, which is kind of nice. And we see a bunch of float 64s and an int 64 in there. So again, I can ask this how big this is. And it's not a huge data set here. So, but I thought this was interesting. And again, what I'm going to show you, I think, is generally applicable to most data sets. So, okay, if you look at this like this int64 here, again, this is not a Python type. This is a 64-bit integer. And, that might be good, but it might not be good, right? And so generally, Pandas and Polars, friends like that, when they read in these files, if they don't have a type, they're going to be a little bit liberal and maybe compensate for that. So I'm going to just ask, when I get a data set, I just ask it, let's select all of this int64 columns, and let's just look at those. Okay, and so this is how I do that. This is one of the ways to do this in Polars. I can say okay, these are the columns I care about, and then from this I'm going to do select. Remember, this is this thing called a context, which kind of materializes into a view. And then I'm going to say this, pl.column, and then pl int64. So this is kind of different. This is an expression in here. So note that I'm just saying I have this column thing that's an integer, and it's a 64-bit integer. I just want you to select those. I only have one of those in here. It's like the elapsed seconds on my ride. And so, this is using 64 bits to store this. It looks like it goes up to 10,000 seconds, so probably not necessary to use 64 bits. Similar to Pandas, I can do a describe on this as well. It's not exactly the same. Like in Pandas, this would be an index over here with a description. Here, since we don't have an index, it's going to stick in this statistic column. And then what I like to do is just sort of look at the max here and maybe the min. And in this case, since I was only writing for 11,000 seconds, I probably don't need 64 bits of information in here. Now note that this code that I wrote up here is starting to get a little bit, I don't know, like where it says 12, the code up there, it's fine code. But if you gave me this code as a colleague, my eyes might glaze over because there's a lot of syntax going on there, right? It's you got the square bracket thing going on, then you got the select method, and then you got some things inside of the select method, and then you got the describe. And to me, that's just a lot of visual noise, and it makes it actually hard to read. So I would prefer to write this code like this. It's the same code, I just put parentheses around it. But the point is that when I write it this way, each of these lines reads like a single step that I'm doing to my code. So this is called chaining. This is something that if you're using Pandas or Polars, I recommend doing something like this. It makes it really easy. I can just say like, I can just come in here and comment this out and just kind of walk through it, right? So here's my data frame, and then I'm going to select the columns that I care about, and then I'm going to select the integer columns from that, and then I'm going to do a describe on that. So if I could like read through this, and it reads through like step-by-step instructions about what I want to do to that. So if there's one thing that you take away from this today, even most of you are Pandas people, if you think about writing your Pandas code as a chain, I believe that's a constraint that forces you to think about the steps that you're working with on your code, and it's going to make your colleagues a lot happier, and you are a lot happier when you come back to your Pandas code and can actually read it. Now, to this point of like, is this int64 too big? NumPy has an IInfo that we can ask it, like, what are the ranges of these things? So I'm going to say, like, what's the range of an int 8, and it goes from like -128 to 127. So we couldn't do an int 8 here, but maybe we could do an int 16, and this goes up to 32,000. So I could probably change this to an int 16. Again, this is not a huge thing, it's not a huge data set, but you could imagine if you have pretty big data sets, that might be useful here. And so here I'm going to use some Polar's code, and this is how you would change this with Polar's code. So select here, select is this context that selects columns, and you can specify which columns you want. So I put in the list of columns that I did want in there. I don't strictly need to do this, but one of the things I like to do is be positive about what I want in my data. And so if I have this list and I see this code, I know automatically, like, these are the columns that I'm working with. It makes it easier to work with. Now, with columns is a context in Polars, and with columns, what that says, it says, I want to make or update a column. So here I'm saying, let's take this PL call elapsed, and let's cast it to an int 8. Now note, in Pandas, if you were doing this with Pandas, you would have like a series that you would pull out, right, and then you'd do a cast on the series to cast it into this type. Note that I am not pulling out a series. In fact, I'm not even referencing the data here. What I'm referencing is something that says this is a column and it has this name, right? So this is a little bit different. This is, again, this notion of an expression, and then it's just going to say, okay, there should be, when the query engine gets this, it says, okay, there should be a column called elapsed, and we want to convert this to an int 8. Let's run that here, and when we run it, we actually get an error, and it says, I can't do this because, like, a lot of these values failed converting here, which is kind of nice. Some versions of Pandas will actually let you do this, and you'll have integer overflow. Some versions of Pandas actually warn you against that. But we can change that to an int 16. I'll just do an int 16 there and then tack on and describe. And then you can check that to make sure that like your elapsed values, don't lose anything. And like, yeah, we're good with doing that. So I'm comfortable doing that. We can look at the estimated size. Again, we're going to save a teeny bit of memory here because we're using 16 bits for that instead of 64 bits. But you could imagine a different data set which was mostly numeric, right? If you can convert those to smaller numbers, it tends to work better. And you might think, like, why do you care about numbers? Well, these Pandas and Polars are what I would call small data tools, right? So they generally want your data in memory. And so, even though things like Spark and big data tools are cool, as soon as you go to a scale-out system, you have a bunch of overhead. And if you can run something on a single machine, not only is it simpler, but oftentimes it can be a lot faster to do that. And so, also these days you can rent machines that have a lot of memory in them. And so if you can fit something on a single machine, especially using something like polars, which can run it pretty fast, you can get some big wins by doing that. But you do need to have some overhead generally, and saving space can allow you to process more data or fit a little bit more data on your machine if you need to. Okay, so again, not a huge savings here, but again, you can imagine if you had multiple integers, you could do something like that. You could go through a similar process with floating points, but for the sake of time today, I'm not really going to do that here. Another thing you might want to look at is strings. So again, in this case, I don't really have any string columns in here. I have like that null column, but I can use this with columns here. So with columns, again, is going to allow me to create a new column or update a column. So I'm going to say, I want to take the elapsed column, we'll cast that to an int16, and then I want to make a new column called course, and that's this thing, PL_lit. So that stands for literal. And it's just saying, I just want this. The course that I crashed on was called maple syrup. So we're just going to stick in maple syrup in there, and you can see now maple syrup is a string instead of a null column there. Okay, in this one, I don't have a ton of different columns, but you might have a data set that has categorical information, something like that. You can get some quick wins by converting strings to categoricals, and that's another thing that you can do to just shrink your data without losing any granularity in polars. Another thing I want to do is make sure that my times are correct. Again, in this case, like I want to find out when I kind of know when I crashed, but I want to know zoom in on that. And so you want to make sure that your times are correct. So the default time zone in here, if I get rid of this. So again, the nice thing about this, so a couple things to note. You'll see that I'm just building up this chain here, right? I'm working with the raw data and I'm building up the chain. I'm not storing intermediate variables here. And that's by design. A lot of people, when they're working with Pandas, will make df1, df2, df3, df4, df5. Anyone familiar with that? Okay, yeah. If you kind of go to this chaining methodology, you don't deal with that, and it makes it so your code runs as well, right? Generally, I don't care about the intermediate variables. I care about the raw data, the input, and the output, and I don't care about the 50 steps that I do, and I don't want to store the 50 steps that I do in between. Okay, so in this case, if we look at this, this is in UTC, and I want this to be in Denver since I live in Salt Lake. So how we do that, this looks kind of similar to Pandas, but again, we're not referring to a series here. We're saying there is a column that has the name of time, and presumably that's a date. Similar to Pandas, it has this DT accessor on that, and then it has this method on there called convert time zone. And when I run that, you can see that this moves into the Denver time zone there. So similar to Pandas, but not exactly the same. Methods are different, etc. Pandas, if you look at a data frame in a series, both of those have 400 attributes on them, all these things that you can do with them. If we look at an expression of a column here, there's not 400, but there's a lot of things that you can do with this, over 200. And then there is the DT namespace in here, and there's other namespaces like str and list in here as well. But if we look at the DT, there's a bunch of things that we can do with the DT as well. So there's a lot of functionality sort of packed in there. And again, the idea is that we use these expressions to build up operations. And when we're doing that, the query engine is going to be smart and know that we're staying in that fast. We're staying in the fast playground, so to speak. Okay, let's talk about missing data. Missing data could be problematic, especially if you're doing machine learning. A lot of machine learning algorithms don't like missing data. And a lot of people, have to clean up their data, and they have missing data for various reasons here. So one of the things that you can do with a data frame in polars, you can say null count here. And one thing to be aware of in polars, this is different from Pandas as well. In Pandas, when you have missing value, what's the missing value? What does Pandas use for a missing value? Nan, right? What does nan mean? It means not a number, right? Which actually Not a number does not mean missing value. It means not a number, right? But an artifact of using NumPy is that NumPy, if NumPy can't store a value, it puts an nan in there. And so Pandas sort of use that. Polars has both nulls and nans. So a nan is a mathematical result that when you can't represent a number after some operation, you can have a nan. And a null means there's not a value there. So Polars has both of those. That might be something to be aware of. So here we're doing null, and we're doing null count. And if you look at this, you can see that like speed between has a missing value, and it looks like rolling traveled and rolling elapsed have 4 missing values. So what I can do here is it turns out that this expression has an is null on that as well. So I can say, okay, let's select where like rolling between is null. And when we do that, this is giving us, so select gives us back a column. And so this is saying, I want the column where this is missing. And this is like, okay, it's missing here, here, and here, right? The nice thing about this is like we can use this sort of process to say, okay, I want to dive into the data, I want to select that, but then I want to look at the rows where that is. All I have to do is change the select to a filter. So this is the same as this up here, it just has a filter instead. And when I do this, this is going to say where these values are true, where this expression is true, return me these rows. Okay, and so you can see that like rolling between is missing over here. There's a lot of values missing. So this is a quick way to just dive into where my data is missing and see what's going on there. Now again, Polars treats nan and nulls differently. So there, like this, there's a null count. Sadly, there isn't a nan count. I don't know why that's the case. I probably asked, and like the next release might have that next week, but I haven't asked. Maybe I should. But anyway, if you want to do that, there's another way to do that here, which is using this CS. So CS, I imported that above. That's a selector namespace from Polars, and it's just a bunch of shortcuts to select columns. And you can say like CS numeric, and that would select all the numeric columns. And so I'm saying, okay, this is an expression, and then do like, is it nan, is the value nan, and then sum those up. And so here we can see that like the only place where we have a nan is actually average velocity, and there's one average velocity missing right there. But then again, this is really easy. I can select that if I want to, select where average velocity is nan. You can see that's the first row. I change that into a filter, and that filters out where average velocity is nan. So once you start getting used to using these expressions, they're pretty powerful and pretty convenient. Okay, so I'm going to assume that like this is kind of cleaned up at this point. I could go through and like fill in some missing values or whatnot, but you know, in the real world, if I'm dealing with client data, I might have a much larger example where I've made this chain. I've kind of walked through the columns and cleaned them up and set the types and maybe change the time zones, or if there's missing values, I've done that. And what I'm going to do is I'm just going to put this into a function here. So because I've formatted it like this chain, it's actually really easy to put into a function. You just like name the function. Naming the function is probably the hardest thing about this, and then you just say return the chain here. So let's just run that and make sure that that works. It looks like that does work. Okay, so I've talked about chaining a little bit. This is called flow programming. This seems to be super controversial with people in the internet. I don't know why. So anyway, a lot of you are Pandas folks, and maybe you don't chain your Pandas code. So my ask of you, or my challenge to you would be, if you write Pandas code, try and think of writing it as a chain rather than storing all the intermediate variables. What that's going to do is, again, it's going to force you to think about these are the steps, and your code is going to read like a recipe. Now, one of the common complaints that I get when I do this is like people are like, I can't debug that. How do I debug it? And I think a lot of people are confused because they see this big chain. They're like, he must be some programming god. He just wrote this big chain and it automatically worked. What they don't see is like, I didn't start with a chain, right? I started with each individual step. I added them. I'm checking my code as I'm going and making sure that it works. Another complaint is like, I really want the intermediate data. I don't really buy that, but I don't care about the intermediate data. I care about like, this is the data that's coming in, this is the data that's coming out, but I'll show how to get the intermediate data here in a moment. Okay, so I made this chain here, and this is actually more important in polars than it is in pandas, because polars can actually take advantage of this. So here I'm just saving this as a Parquet file, but right here in polars in addition to having like read CSV and read Parquet, has scan. And what this scan thing is it's lazy. So instead of giving you the data, what it's doing is it's saying, okay, I have something that is tabular, right? And then it's saying, okay, it's actually a lazy data frame, kind of like a generator, but then we're going to pass this lazy data frame in here, and then we're going to do a selection on that, then we're going to add this row index, and then we're going to add these columns or whatnot. And again, this isn't doing a lot here, but you could imagine something more complicated where we might do a filter or a group by or something like that. And because Polars has a query engine, what it can do is it can actually know that because I'm only using these columns in my final result, I don't even have to load all the columns, right? It can be smart about that. Or it can also know that, like, because I'm filtering out these rows, I don't need to read those rows initially. When I'm reading the CSV file or the Parquet file, I don't even have to read those rows. I can skip over them. The query engine will allow it to do those things. It will also allow it to do things like pin your CPU if you're doing a group by or something like that. So super nice. Note that when I run this, when I change this to scan, I don't actually get a result here. I get this query plan. If I want this to actually run, I can say collect. Okay? And so this actually runs that. So this is cool, like the same code. I just changed this from, from read Parquet to scan Parquet, and I get laziness and potentially like a huge improvement there. Another thing to be aware of, this was just announced last week, but I had preview access to this. So NVIDIA is working with the creators of Polars, and NVIDIA has basically implemented a backend for Polars. And if you have a bunch of NVIDIA cards and you're not leveraging them to Pam for training her data for improv, you can use it for actually doing tabular data processing really quickly. And so all you have to do is you just say collect and then say GPU, and it will run the same code on the GPU instead of on your CPU. So, that can get, Polars is pretty fast, but I saw like a 10x improvement in my Polars code by pushing it to the GPU, which is kind of cool. Okay, so debugging, how do I debug this? If you really want the intermediate variable, I do the same thing in Pandas as well, right? So there's a pipe, which is just a generic method. Pandas and Polars both have these. You pass in a function, and then the function takes the current state of the data frame, and you can return whatever you want. Generally, I return a data frame so I can continue my chain. But sometimes I'll do a pipe like this where I'm going to say, okay, I just want to know what the shape is at this time. This is actually useful when you're joining, right? You can see like if you have some weird combinatoric explosion when you're joining your data, just debug the sign before and after, print the debug before and after, and make sure like you don't have like 50,000 times as many rows as you had before. So that I'll show. Well, we'll just run that, and you can see like there's the output from that right there. Right. I also put in another pipe right here, and I have this function called getVar. So this is for the person who says like, I really want that intermediate variable. If you really want that, if I was debugging this, I'd just comment it out and like walk through it and like step through it. It's not hard. It runs pretty fast. But like if I really want that, I just can use this. And all this is saying is like I'm taking the current state of the data frame, and here's a variable name, and just jam it into globals, and then just return just return my data frame here. So at this point, after I run this, here is the intermediate variable if someone really wants that. It's not hard to get with a chain. The other nice thing about this is like a lot of people will write their code, like in Pandas, they'll mutate their code, and it makes it so like if you need to recreate their code and you're mutating all over the place, it's really hard to know like, has this already been mutated? Can I rerun this again? Is it actually destructive? this, this is idempotent. It runs without problems and should run consistently there. Okay, another thing that, so I feel like I'm just up here ranting, but I'll rant some more. So another thing that I see a lot, so because, I do a lot of Tabular stuff, I've written a lot of Pandas stuff, I tend to get like spammed by like companies like, you should read this thing about Pandas because whatever, Google thinks that I like Pandas for whatever reason, so it forwards me all this Pandas stuff. So I read a lot of it, and a lot of it's okay, and it seems like a lot of it's maybe like students or people are like, oh, if I start a Medium blog and I write like 20 things about pandas, then I'll get some posts and maybe I'll get an internship out of that. And okay, that's awesome, like this person got some attention, but the thing I don't like about that is it seems to be like this echo chamber where people keep repeating bad advice. And then you see like all these like LinkedIn posts or Twitter posts or X posts where it's like, do this, right? And it's like, actually don't do that, but it's been repeated so much that even like the AIs, like if you ask the AI how to do it, it's repeating this bad advice of how to do things. So one of these is like apply. So there's an apply method on like pandas, and in Polars it's called like map elements, and people are like, oh, this is really cool, I can define a Python function and then I can apply it or map elements to it, and then every piece of data in my column will go through that Python function, which is kind of cool, but again, you're going outside of the sandbox now, right? Because now you're in slow Python land. I see this all over the time where it's like, just put apply and put everything in functions and your code will be easy to read, and turns out super slow as well. So let's give an example here. This would be an example. So this for whatever reason, Strava gives me back information in meters, and I live in the US. I don't even understand what a meter is. So I want it in terms of feet. Sorry, rest of the world, if you're watching this on the internet. Yeah, you probably don't care about this, but let's say that I do care about this. So if I'm the naive person, I'm like, oh, well, I have this function that's like convert it to meters to feet, and then I can say, okay, look at this is awesome. I can just say meters to feet. This is like functional programming. It kind of makes my brain hurt, but it's cool. It's easy to read. And then I run this, and Polars actually, look at this. Polars is like, Polars inefficient map warning. If that wasn't a useful warning, I mean, it did it, but it's like, you're kind of a bobo here. Okay, map elements is significantly slower than using the expressions API. Only use this if you absolutely cannot implement your logic otherwise. And look at this, it actually tells me, like, this is how you do this. Wow. I mean, yeah. So this is kind of cool. I mean, just another rant. Like, one of the things that drives me crazy is like there's like a warning or an error. It's like, I can't do this. And it doesn't tell, it says I can't do this for whatever reason, but it doesn't tell you like the piece of data that it failed on. It just says, I can't do this. You can go find the data. I'm not going to tell you. I know it, but I'm not going to tell you, right? And this is like going like all the other way. It's like, not only is this dumb, but you can actually do this way and it will be a lot faster. Okay, so here's my result, right? And then I'm like, okay, US-centric. Oh, now it makes sense. Yeah, this was the elevation. I'm like, who knows about those meters things, right? But so actually using the same code, you can actually get this to play inside the sandbox. All I have to do is like pass in my expression into this function. Instead of mapping it, I can just pass it in there directly. I mean, if I run this, it's the same. And this is small data, like who cares? It takes like whatever, however long to take. But if you have a larger data set where you actually care about performance, and I would venture to say like one of the main reasons most people would want to move to Polars from Pandas is because they care about performance, right? If your Pandas is slow, presumably your Polars can be faster. Alternatively, we could, if you really like that functional style, and you're like, look at this is cool, I'm passing in a function, I'm not calling it sort of thing. If you use pipe, it's actually doing it the fast way as well, so this works as well. So I ran this here. I'm going to run this. It's just going to print out a bunch of junk here because it keeps printing out this warning here. But this takes like 965 microseconds, which again, who cares? I don't even know what a microsecond is, like 900 of them. On this data set's so small, it doesn't really matter. But you know, if I run this using the smart way to do it, right, it takes like 37 or 36 microseconds to do it, right? So, you know, a simple calculation is like it's 25 times faster on this data set to do it like the smart way, right? And in this case, it doesn't matter, but you could imagine if I have something that takes 20 minutes to run, right, if I can get that done in 20 seconds, that's a pretty big win for me, right? Again, caveat, people hate benchmarks and whatever. So if you are benchmarking, especially Pandas or Polar's code, make sure you're benchmarking it with the size of the data that you're using in production, not you're using some really small data set and like, oh, I tried it with 10 rows and look how fast it was, right? But we have 50 billion rows in production. Make sure you're using the same size there, because some of these tools might have different fast paths that they go down depending on the size of your data. Okay. Another thing that generally applies for people dealing with tabular data is this notion of aggregation. And I like to say, like, aggregation, these are the things that your boss wants to know, right? So let's imagine that, like, you're working at, I don't know, the candy store. You're the cashier at the candy store, and the boss comes in and says, how are we doing? And you say, like, Billy bought a Tootsie Roll and a lollipop and a stick of gum, and then Susie came in and she bought 3 candy bars and a Tootsie Roll and 2 packs of gum. Your boss is like, I don't really care. Tell me what happened. Well, there were 55 customers who came in and they spent $967, right? That's an aggregation. That's the stuff that your boss wants, where we're taking a bunch of data and collapsing it. And so these are the things that, you know, I find that, like, when I'm teaching someone, they're like, oh, this is where, like, the rubber meets the road, or like, oh, we just have these insights because we can formulate these solutions very quickly, or it's like, oh, this training totally paid for itself with this 5-minute discussion based on this aggregation that we did right here. Okay, so, you know, I was kind of thinking, like, what are some aggregations that I could do with this data? Maybe these are silly, but like if you look at, like, Strava, you can actually see, like, aggregations that they do where they, like, say, here's the first mile, this is what you did in the first mile, right? This was your pace for the first mile, here's your pace for the second mile, etc. So I'm going to do something similar. I'm going to say I want to like aggregate by 10-minute intervals, and let's look at how far we went and what our speed was over those 10-minute intervals. And so Polar's has a thing called group by dynamic. It also has group by. Group by dynamic is basically when you're grouping with time series. So if you've used, like, PD Grouper for Pandas, this would be like the Polar's equivalent here. This is really cool. Look, I can say, like, here's my index column. It's weird here. It says index column. What even is an index in Polar's? I don't know. Polar's doesn't have an index, but apparently you need to specify the index column. But this is the aggregate. You know, we're going to aggregate by this column here. So time, right, which is a time series, and I'm going to say 10m in a string here. So this is similar to your offset alias in Pandas there. And then we're going to say, okay, we're going to do this aggregation, and I'm going to take the traveled. And again, note that this is not referring, there's no, like, Pandas series in here or Polar series. This is just saying there is a column called traveled. We're going to take the last one of that, and we're going to subtract the first one from that within every 10 minutes. And that should be, like, how far they traveled. And then we're going to make another column called speed, and we're basically going to take that traveled thing there, and we're going to divide it by the elapsed time, and we're going to say total seconds there. And then at the end here, I'm going to say, oh yeah, and because I live in the US, please convert meters per second to miles per hour so I understand what you're talking about. Okay, and I can do that, and I get something that looks like this, right? And so, again, there's no index here, but time is in the left-hand column there, and you can see that this is every 10 minutes. This is really cool because I can come in here and I can say, like, oh, every 13 minutes, right? Or every 15 minutes, or change, you know, super flexible once you understand how to do this. Now, again, the syntax is a little bit different from Pandas, but if you're familiar with Pandas aggregations, it's somewhat similar. And then generally, you know, once you have something like this, you know, I worked with a company and they're like, we want to see the data. And I'm like, no, you don't want to see the data. And they're like, yeah, we want to see the data. And I see this repeated all the time when I show people like pandas or polars. I'm like, pandas is only going to show you the first 10 rows and the last 10 rows and the first 5 columns and the last 5 columns. They're like, how do I see more data, right? And I generally tell people, well, you can see more data, but if you're asking that question, like, how do I see more data, your spidey sense should go off. And you should be asking yourself, can I use a computer to view the data that I want to view, right? I actually don't want to scroll through a million rows of data. And if you do, more power to you, but your boss probably doesn't want you to do that. So can I use a computer to filter it, or can I visualize it, right? And a good visualization can tell a story quite well. One of the nice things about these aggregations is generally once you have an aggregation like this, it's really easy to, it's actually in a format probably for you to visualize. And all we have to do with polars here, a recent version of polars added Altair as a plotting engine. And so I just tack in this plot.bar, which is pretty similar to your pandas plotting there, right? And you see like, okay, this is my miles per hour based on my time, right? And yeah, so long story short, like right in here, I think I crashed at 7:07. So this is like going downhill, going pretty fast. This is all downhill over here, but because we walked out, so it wasn't going fast over there. And you can do more things like this. You can say like, okay, maybe I want to compare like uphill versus downhill, right? So this might be a little bit more involved, but I need a column called, am I climbing? And so how do I calculate that? Well, one way might be to like look at the difference between the elevation, and if it's greater than 0, then that means you went uphill in the last second. And then we can group by that column that we just made there, and then we can aggregate the distance within those groups, and then we can filter out where climbing is null. I think the first row climbing is null there, and we get something like this. So, how far have I gone uphill versus how far have I gone downhill, right? So actually went more uphill than downhill because I started riding from my house and then I had to get picked up and taken to the hospital, so I didn't actually get back down to my house on that. And again, you can plot this. All we have to do is tack on a bar here, plot.bar, and visualize the relationship between them. Okay, so that's kind of what I had to show you today. So in summary, people have messy data, especially if you have like CSVs. Go through that, make sure you understand the data. Another thing that I hear is like, can I just have isn't there just code that I can do to like clean up my data and do this automatically? Yeah, there are tools that will do stuff like that. I mean, you can think of like AI doing some things like that for you. However, generally, I'm moving on to things like doing modeling and predictive models after this, and my take is, this might be, I don't know who's in the audience here, but my take is that like if you understand your data and you really understand what's going on with your data, you can make a very good model with it relatively easily. Much better than like not understanding your data and throwing it into some like auto ML thing to like try 50,000 different models and try and pull something out. If you understand your data, generally you can make a simpler model that performs better, and when your boss comes back and asks you what is going on with this, you'll actually be able to tell her what the answer is. So I do actually spend time walking through the columns. I think is super useful when you're working with data. Doing that by hand, I think, is useful as well, just to understand it. Again, chaining. I think chaining's, from my experience, super important. I get feedback all the time from people who are like, I was really skeptical of chaining, but then when I tried it, it actually worked and made my code easier to read. I think it's kind of similar to like white space in Python. Often I'm in like a beginner Python class, and people are like, isn't there like a white space thing in Python? And they're like, yeah. And then we get to it, and they're like, that was it? And it's like, yeah, that was it. It's not generally an issue after like 5 minutes of explaining how white space works in Python, but people have heard so much about that. So yeah, chaining, especially for polars, because polars has the ability to be lazy and use that query engine, it's even more important to chain your code in polars if you want it to be fast. And I think a lot of the reason why people want to use polars is to make it fast. Don't do silly things like map elements, slow for math. And then aggregations, I think super powerful. And the syntax might be weird or different from Pandas, but once you get used to it, once you understand it, very easy to start swapping those things out or answering different questions with those. Yeah, so that's what I had today. Hopefully, if you're considering using polars, this gave you sort of a feel for what polars looks like and compare and contrast it with Pandas. And thanks for coming. Again, I'm going to do a book signing here later. I have a few copies of my polars book, if you're interested in that. And yeah, if there are questions, happy to take some questions.
Thanks very much for your talk. I love chaining for all of the reasons you have up there. I suppose in realistic applications, I worry a little bit about the query planner eating very long chains efficiently in a world without indices. Is it taking statistics? Can you give it any hints? Can you tell it to optimize for memory or time, et cetera?
Yeah. Yeah, so the question is, like, is a query planner going to work with long chains? So query planner does know about things like sorted columns, right? And if you have sorted columns, it can do smart things. Sometimes you have to give it a hint where you say set sorted, so it knows how to do things in that way. So, yeah, again, you know, is it possible to write like assembly code that's faster, right? Possibly, right? But who wants to write assembly code? And the other thing is you can try it out, right? If you've got a long chain, you know, break it up and see if it speeds up. Another, you know, and I'll maybe one more caveat is, like, I say use chaining a lot. There are places where legitimately, like, you can't chain, right? Yeah, you have some DAG or something like that where you're depending on two things, and it makes it harder to chain. So I'm not saying that, like, chaining is the only way to do things, but my recommendation is that, like, in general, I think it's a constraint that forces you to write better code if you can think of it that way.
And I'm sure the planner is getting better too.
Yeah, yeah.
I have a quick question. As we're running out of time, I have a quick question. I'm sad that you got hurt and that you had the accident. But as a bicyclist, I have to ask, how was your bike?
Wow. So it's my wife's bike. The computer mount broke, but it's otherwise okay. And I'll say wear a helmet too.
Yeah. So we have another speaker coming up at 12:15. Matt will be signing books.
Yeah, I can take stuff out in the hall too.
Yeah, and he'll take more questions. Thank you so much. We have another speaker coming up. Another round of applause. Great.